Hi, 8th grade. Today we are going to continue in Chapter 11, moving on to Lesson 6, Adding and Subtracting Rational Expressions. I'm going to dive right in. Our skill is to find each sum or difference. Our first example looks like 8c plus 5c. Both of these are fractions. Their denominators are 6. When the denominators are the same, we can combine them to 8c plus 5c over 6. And because both 8 and 5 have the same label, they can be combined into 13c over 6. Let's do another one. This time, let's say we have 4t and 5xy on the bottom plus 7 over 5xy. The denominators are the same, so we can combine them. 4t plus 7 over 5xy. 4t and 7 do not have the same label, so it cannot be simplified further. That would be our final answer. You guys ready to try one? Here's yours. 3y over 3 plus y plus y squared over 3 plus y. Before you finish on this one, you should notice that the top can be simplified. So I would pull out a y, and then you're left with 3 plus y, which leaves you with the same thing on the top and the bottoms, so they can cancel, which makes your final answer just y. So be careful. We are going to be factoring or simplifying today. Okay? Let's do another one. 2h plus 4 over h plus 1 minus 5 plus h over h plus 1. This is our first subtraction problem, okay? This subtraction is like a -1, and it needs to be distributed to both or all, in case there's more than two, of the factors that are in that second piece. So I would rewrite this as 2h plus 4 minus 5 minus h, all over h plus 1. And so now when I combine, I've got a -h and a 2h, and then positive 4 and -5. So 2 minus 1 is 1h, and a positive 4 and a -5 is -1. So I end up with h minus 1 on the top and h plus 1 on the bottom. And because they're not the same sign, that's as far as I can factor. Try one like this. 17h plus 4 over 15h minus 5. This one's a subtraction problem. 2h minus 6 over 15h minus 5. Pause it. Final answer should be 3h plus 2 over 3h minus 1. Okay? All right, let's take a look at another type of problem. T squared over t minus 3 plus 3 over 3 minus t. You'll notice that these are in different order, so they're not the same. If I was to switch this, it would be -t plus 3. That's what, if I switch them, it looks like this, -t plus 3, which is not the same thing here, right? So when I switch them, I really need a -1 on the outside to change the signs, okay? So if I write it that way, the first one stayed exactly the same, t squared over t minus 3. But the second one I write with that -1. right? Because I needed that to change the sign so that the t wouldn't be negative and the 3 would. So I have to show that. And when you do put that negative here, it makes this whole thing negative, right? The whole piece is negative, the top, the bottom. So when you combine it, we now have the same thing on the bottom, t minus 3, t minus 3. And on the top, we have t squared minus 3. This cannot be simplified any further. Let's do another one. Let's do another one just like that. Okay, here we go. 3x over 11 minus x, negative 5x over x minus 11. So again, I have the wrong order here. So if I switch it, I have negative 11 plus x, and I want them reverse, right? So I'm going to multiply by negative 1 so that negative 1 times negative 11 is positive, and negative 1 times positive x gives me the negative that I need here. It's so that I can switch the signs for what I need. When I do that, I end up with 3x over 11x stays the same. And this one, I have negative 1, and then my new order, right? 11 minus x, and the top stayed the same. What you notice, what I've circled here, is that I have now a double negative. Okay, so this will not change the whole fraction like it did in the last one to negative. Instead, it changes this one to positive, right? Because 2 lines make a plus sign, right? Double negative. So then, when I combine them, I have 3x plus 5x over our original denominator, okay? When I finish, I end up with 8x over that denominator. You try. 2p over p minus 1 minus, so be careful here, 2p, 1 minus p. So the first thing you want to do is change the order here, and in order to do that, you're going to need to multiply by a negative 1. You should get, pause it if you need more time, 4p over p minus 1. Skill number 2. Find the LCM, the least common multiple. So, I know in 5th or 6th grade, you were taught how to find the least common multiple when you had numbers. And it's not going to be different today, just it's not going to be the same like simple numbers. We're going to be using trinomials and binomials and variables. So let's take a look at an example. If I have 8m squared t and 12m squared t cubed, I need to first factor it down. Okay, so like in 6th grade, I know because I teach it, we use the factor tree, right? And so some of these you already know the factors, but I'm just trying to jog your memory. So if I factor 8, that's 2 times 4, and then 4 is 2 times 2. And we leaf or circle the prime, okay, when they can't be reduced anymore. So this is 2 times 2 times 2. And then if I do the same for 12, that's 3 and 4, which is 2 times 2 times 3, all primes. So that's 12 is 2 times 2 times 3. Okay? Okay. If I break down the factors of the variables, m squared turns into, so we've got 8 here, and then we've got the rest over here, 2 m's and a t. Here I've got the 12 broken down, and then I've got the rest of it over here, right? So m squared t squared is 2 m's and 3 t's. So step 1 is to factor. And then step 2, we want the largest group. We want to make sure everything is represented, okay? we want the largest group of each. I'm just going to say each because whether it's a factor or a binomial, whatever it is, okay? Numbers, etc. So in this case, the LCM, if I'm working on this, if I check 8, I have 3 2s, and if I check 12, I have 2 2s. So the largest group is 3 2s. So I'm going to take 2 times 2 times 2, and I'm not going to use the 2 2s because that's smaller. And then there's nothing else from 8 to use, but on 12, there's a 3, so I'm going to throw in my 3. The largest group of 3s that I have is 1, so I'm going to add that to my LCM. Then if I check my variables and compare them, I've got 2 here and 2 here, so it doesn't matter which one I pick, okay? Just need to make sure that they're going to be included. And then t's, I have 1 here and 3 here. So I want the largest number, so I'm going to take these. So t cubed. 2 times 2 times 2 is 8, times 3 is 24. So the LCM is 24 m squared t cubed. Okay. Let's take a look at some trinomials. We've got our trinomials here. These are the two we're supposed to find the LCM for. So we want to factor, and then we're going to use the largest group of each, okay? So if I factor this, right, I'm trying to think of what I will get that equals -8 when I multiply and -2 when I add. So I'm going to use -4 and a +2. So x minus 4, x plus 2. And I'm going to do the same thing for 14. Oops. 14 and -5. So -7 and +2. X minus 7, x plus 2. So for this one, for my LCM, I need to make sure I have the largest group of each. Everything should be represented. So in this case, I have an x minus 4, only one of them, and I have an x plus 2. For my second trinomial, in this case, I have x minus 7, it needs to be represented, and then I have an x plus 2, which I already have. I already have 1, and since they're already grouped, right, I can only take the largest within the group, so I don't need to write this again. This will be my LCM. All right, how about you try one? You try one. Here you go. X squared minus 3x minus 28 and x squared minus 8x plus 7. Once you get it, check to make sure it matches mine. You should get x minus 7, x plus 4, and then from the second trinomial, we're only going to take the x minus 1 because x minus 7 is already there, okay? It's already represented. For homework tonight, we're going to be on page 716. And we're going to do numbers 15 through 25 odd and 27 through 32. Have a good weekend, guys.